Hey guys, quick review here. Potential energy and kinematic energy. Let's say we drop a ball. At first the ball is not moving. No movement, no kinematic energy. We only have the potential energy given by gravity. As the ball starts to go down, that potential energy will decrease and the kinematic energy will increase until it reaches the bottom where the potential energy is zero and the kinematic energy is at max. Let's say we need to raise an object. We need to apply a kinematic energy. When that kinematic energy is depleted, the object will reach the maximum height. And from there it goes down again. So it's an exchange from kinematic energy to potential energy and then potential energy to kinematic energy. The roller coaster problem is the same principle. Let's say we need to raise an object 30 meters, so we apply a force and the force necessary to make the car go to the top, and then from the top we know that the potential energy is 100 and the kinematic energy is 0. So what happens as the car starts to go down? For example, in point B, we know that the potential energy is less than 100 and the kinematic energy is greater than 0. And at the bottom, all that potential energy became kinematic energy. In space, the potential energy is 0 because there is no gravity. In order to launch an object to space, we need to reach an escape velocity equal to 1.12 times 10 to the 4th meters per second. Conservative forces. So why gravity is a conservative force? Because anything that goes up, it has to go down. If it falls in the same place, it didn't move, so there is no work there. Elastic force. If you stretch a rubber band and release it, the band will shrink to its original size, so there is no work there. And electricity, because in order to have electricity, you need to have a closed circuit like the loop that I have in here. If you open the circuit by cutting a cable, you won't have any electricity. Conservation of momentum. So we're given this formula. Momentum is equal to mass times velocity. At first, we know that the momentum of both the gun and the bullet will be 0 because the velocity is 0. But then we're given the velocity of the bullet after fire, and we have to calculate for the speed of the gun. So we just replace the values into the original formula, and we get that the recoil is equal to negative 12.5. Impulse is equal to the change in momentum. So if in a problem we're given momentum instead of impulse, it's the same thing. An increase in the time of impact decreases the force. We're giving an example where we have a floor of tile and then a floor of carpet. And we're asked what object will hit the floor with the greater force. In the tile floor, the impact is almost immediately, so the force will be greater than on a carpet floor where the time is a little bit longer. Momentum is always conserved, so we're asked what happens to the speed of a car if we add the weight of another car that weighs exactly the same. So we're basically doubling the size. What happens to the speed? It decreases by half. How do we know that? Well, we know that the momentum at the beginning is the same as the momentum at the end. So we replace the numbers in the formula. We get that the speed is equal to 5 meters per second. Momentum is always conserved, but kinematic energy not necessarily. So on an elastic collision, some of the kinematic energy is preserved. On an inelastic collision, some of the kinematic energy is lost. If we need to calculate the speed of an object that is moving in a circular motion, we can either calculate the linear speed or the angular speed. To calculate the linear speed, we need to divide the length or the blue line that we have in here over time. And to get the angular speed, we divide the angle over time. If we're given, for example, the angle and the radius and we need to know the length, we need to use this formula, but theta has to be done radians. To change any value to radians, we need to multiply the value on degrees and multiply by pi over 180 degrees. The degrees will cancel and we make the division and we get a result of pi over 6 radian. If we're asked what's the direction of the angular speed, we have to know if we go counterclockwise, the direction is up, and if we go clockwise, the direction is down. We can use our right hand to remember. And on this example, two objects are moving on a circular motion, but they have different radius. And we're asked what's the linear speed, where the object with the longer radius will have the longer linear displacement. But if we're asked about the angular displacement, where both objects have the same angle, so it's the same angular displacement.